Hi everybody, welcome to part 3 of chapter 8 motion. This is from class 9 CBSE NCERT book. My name is Avantika. I hope you have seen part 1 and part 2 before you come here because we are going to be talking about velocity and acceleration further ahead. We are going to be talking about the equations and the graphs, etc. So you have to understand the concepts before you can see this. Okay, we will proceed with the third part now. So this is what we have learned in part 1 and in part 2. Okay, in part 1 and part 2 we have learned that motion is a change of position which is described in terms of distance or displacement, right? Displacement is distance with direction. Motion of object can be uniform or non-uniform depending upon whether the velocity is changing or constant, right? If the velocity is changing, it is non-uniform motion. Okay, the speed of an object is the distance covered per unit time, whereas the velocity is the displacement per unit time. And acceleration of an object is the change in velocity per unit time. Okay. So a graphical representation of motion. This is what we are going to be studying here. So graphical representation, can be done on bar graphs, on line graphs and stuff like that. Okay, so you have a graph paper, you have to plot points and then you join them to get a trend, right? So it can either be bar graph or line graphs, but in this case it is a line graph. Okay, a straight line graph helps in solving a linear equation having two variables, right? You have two variables, x and y axis, x axis, y axis, and then if you have a straight line, then that will help you solve a linear equation. Okay, we are going to first talk about distance and time graph. So this will give us the change in the position of an object with respect to time, right? So since we are talking about distance, we are going to be talking about the physical position of an object with respect to time. Okay, so we will see how things are moving, how the distance changes with changing time. We take time on the x-axis and distance on the y-axis. And you can plot various conditions, right? You can plot the at what given point of time how much distance has been covered, and you can plot these things, and you can represent various conditions of how the position of an object is changing with time. So objects move with a uniform speed or a non-uniform speed, or can be at rest, right? When they move at uniform speed, what does that mean? They are covering equal distance in equal intervals of time. For example, in 5 minutes, an object will cover 10 kilometer. Okay, so in every 5 minutes it will cover 10 kilometers. Okay, in every 5 minutes it will cover 10 kilometer. What is non-uniform? Non-uniform speed is when the distance covered is unequal in equal intervals of time. Okay, so in 5 minutes, for example, it can move 10 kilometer also, it can move 5 kilometer also, it can move 7 kilometers also. So the speed is non-uniform. Objects can also be at rest, which means they are not moving at all, so distance covered will be 0. Okay, uniform speed, as I said, equal distance in equal intervals of time. And in uniform speed, the distance traveled is directly proportional to the time taken, right? Because both the intervals are equal, the distance is directly proportional to the time taken. Where the speed remains constant, the distance traveled is directly proportional to the time taken. Okay, in this here, this is the graph of uniform speed, which means that the object is covering equal distance in equal intervals of time, right? All of these. So OB, this line OB it shows that the distance is increasing at a uniform rate. Okay, also the term uniform velocity may be used if the magnitude of displacement is equal to the distance traveled by the object along x-axis. For example, if this distance is the same as displacement. When does that happen? When is distance equal to displacement? When it is moving in a straight line. When an object is moving in a straight line, distance is equal to displacement, and In such a case, then you can say that this is moving at a the object is moving at a uniform velocity. Otherwise you say the object is moving at a uniform speed. Okay, and this graph where the distance is directly proportional to the time taken, where it is uniform speed or uniform velocity, the graph of distance traveled against time will be a straight line. Okay, directly proportional, uniform speed, straight line. Okay, you have to remember uniform speed, straight line with distance and time, because in uniform speed, distance is directly proportional to time. Okay, so now we will determine the speed. We have said that uniform speed where distance is directly proportional to time. So now using this distance and time graph, we can determine the speed of the object. How do we do that? What we will do is we will consider this small portion A and C. This is point A and this is point B, for example, right? So we consider this small point A and B, small part of this line. Okay, this is a straight line, so you can take this part and it will be the same for each of them. Okay, so line parallel to the x-axis is drawn from A, from here like this, and parallel to y-axis from B. Okay, so these two lines are taken and they meet at point C and they form a triangle ABC. Okay, now AC here denotes the time taken. Why does it denote? Because it is parallel to the x-axis. So here whatever is the time and here whatever is the time, this is T1. So imagine an object is going uh, from here, this is about 28 kilometers or something, and this is up till here like 38 kilometer. Okay, so this 10 kilometers here approximately, okay, according to the graph, right? So this is about here point A and this point B is about 38. So this is about 10 kilometers have been covered here approximately. So then we say that this time taken is for this point, for at this distance, at when it is at 28 kilometers, this is the time T1, and at 38 kilometers there is a time T2. So this is the time taken to cover this much distance, and BC is the distance traveled. So B and C, this is the distance traveled here. Okay, so this much distance traveled is traveled in this much amount of time. So this is S2 and S1. Distance traveled is S2 minus S1, and time taken is T2 minus T1. Okay, so when an object moves from point A to B, it covers distance S2 minus S1 in time T2 minus T1. Therefore, speed is S2 minus S1 upon T2 minus T1. Okay, how? Because velocity is equal to distance upon time. We know this. The distance traveled is S2 minus S1 and the time taken is T2 minus T1, right? So this is the velocity and this is how you can find it. All right. So here we see in this example, for example, distance traveled is not constant. When the distance traveled is not constant, what does that mean? That the motion is non-uniform, that the speed is changing, right? We have seen this in the previous videos that the distance is not constant, which means that the speed is not constant, that is covering different distance in the same amount of time. For example, if you see this in a car, in these are intervals of 2 seconds each, right? 2 second के interval में once it is traveling 1 meter, then it is traveling 3 meter, then it is traveling 5, then it is traveling 7. So it is not uniform. Okay, it is not uniform. The distance covered is more as it is increasing or decreasing. It is changing, but in uniform intervals of time, right? So distance traveled is not constant, and when this is plotted on the graph, it does not show a straight line. So uniform motion gives a on a distance time graph gives a straight line, whereas non-uniform motion on a distance time graph does not show a straight line. Okay, it is, in this case the distance is increasing, so it kind of shows this kind of a curve. Okay, this is non-linear variation of distance. In uniform there was a linear variation, they were directly proportional. Here they are not directly proportional, they are non-linear. The variation of distance with time is non-linear. Okay, this is for non-uniform motion. And okay, this shows non-uniform motion. You can easily plot these points yourself and see. At 0 it is 0, at 2 it is 1, at 4 it is here at 4 it is at here at 4, and then if you plot these according, you will see that this graph is non-linear. Okay, so we come to the next point is velocity time graph. We have done velocity is distance upon time, and acceleration is change in velocity upon time, right? Distance upon time is speed or velocity. Speed, displacement upon time is velocity, acceleration is velocity, change in velocity upon time. So now we are going to be looking at the velocity time graph. So variation in velocity with time for an object moving in a straight line is represented by a velocity time graph. Now variation in velocity with time for an object moving in a straight line. When it moves in a straight line, velocity is equal to speed, right? And distance is equal to displacement. So it is represented by a velocity time graph like this. In this case, this is uniform motion, right? Distance upon time, डिस्टेंस बाय टाइम ग्राफ में जो ग्राफ था यूनिफॉर्म मोशन के लिए, इट वाज अ लीनियर मोशन where the distance was increasing proportionately with time. In uniform motion, the velocity or speed does not change. Therefore, when you plot a velocity time graph, then velocity remains constant with respect to time. Okay, here we have taken time on the x-axis again and velocity on the y-axis. As I said, it is uniform velocity, which means uniform motion. Velocity is not changing, right? So height of the velocity time graph does not change. It remains parallel to the x-axis. Okay, constant value parallel to the x-axis. And what does this mean? It means that time is moving forward but velocity remains same. Okay, so product of velocity into time will give the displacement. It will give displacement. Since direction is not changing, displacement is equal to distance. Okay, so this area shaded in blue will give the displacement. Okay, this area enclosed by the velocity time graph gives displacement. You can take any of them. You can take any 2 points anywhere as T1 and T2, and then you calculate the area of, for example, okay, you take these points. You take point A here and you take point B here. Okay, you draw a perpendicular on the x-axis, which will be parallel to the y-axis, right? So here also you draw parallel to the y-axis, perpendicular to x-axis, and it meets at these points. This is the time points. So at position A, at point T1, okay, in time T1 with velocity 40 km per hour, it is it is here on A, and at B again 40 kilometers per hour but T2. So this is the distance. If you take the area of this entire thing, it will be the distance. Velocity is represented by height A or C, right, or B and D, obviously, right, because this is parallel to the y-axis. Okay, so AC is equal to BD is equal to velocity. Okay, and distance S is equal to area of this rectangle, which is breadth into length into breadth or breadth into length. So we calculate AC, which is the velocity, and we take time. t2 minus t1, this is the time t2 minus t1, and we multiply this, and thus we get the distance. Since we do not know, we can estimate this, but it's okay. The 1 point something and this is 4, so you can just multiply it by 40 and you can get the area of the rectangle, which means it is the distance traveled. Even normally we know that distance is equal to velocity into time, right? So here you have this case. Okay, here in graphical method you will see that the rectangle gives the displacement or the distance. Okay, so in a uniformly accelerated motion, velocity changes by equal amounts of equal intervals of time. What you saw previously was for uniform motion where the velocity was not changing. Here, velocity is changing by equal amounts in equal intervals of time, which means it is uniformly accelerated. If you do not know the meaning of acceleration or velocity, please see parts 1 and 2 again. Okay, in uniformly accelerated means velocity is changing by equal amounts in equal intervals of time, and this is the graph that you see here. Velocity time graph is a straight line. When something is changing at a constant rate with respect to time, then it will give a straight line, whether it is distance or whether it is velocity. When it is changing with constant at a constant rate with respect to time. Okay, in this case the distance moved is equal to the area under velocity time graph, of course, but in this case it is not a rectangle, it is a trapezium, right? It is a trapezium. So since velocity is changing uniformly, which means it is uniform acceleration, the distance traveled is the area of trapezium ABCDE. The area of ABCD can be calculated by calculating area of triangle and the area of this rectangle. Okay, area of this triangle and area of this rectangle ADE. Okay. Okay. Oh, okay. So what happens is here you see that in 5 seconds, in the intervals of 5 seconds each, this is moving, this is increasing, velocity is increasing by 2.5 meter per second. Okay. If the car had been moving at the same speed, for example, we consider 10, and if it had been 10 here, 10 here, 10 here, then it would have been uniform motion, which would have given a straight line like we saw in the previous slide. Here it is changing with equal intervals of 2.5 meter per second, or by with kilometer per hour, it is by 9 kilometer per hour every equal interval. So it is uniformly accelerated, and therefore we find the area of ABCDE. To find the it is the same thing. You take a perpendicular to x-axis from point A and this point E, and then you also take a parallel to from A and D parallel to the x-axis, and then you can uh, measure this value. Now you have to understand that ED will be equal to this much and AB will be equal to this much. Okay, you have to take those heights accordingly. Area of ABCD will be AB into BC. This is the area of a rectangle, and half into base into height. So half into AD, this is base, and into height. So this is area of triangle ADE, half into base into height, and this is length into breadth. Okay, so these are the formula, and this is how you find the area of ABCDE. Okay, so this is another thing in non-uniformly accelerated motion. We saw uniform motion where there was no change in velocity. We saw uniformly accelerated motion where the change in velocity was constant with respect to time. Change was constant. It was equally changing with equal intervals of time. In this case, it is non-uniformly accelerated, which means that the velocity is not changing equally in equal intervals of time. In this case, the graph could be of any shape. Okay, you can have velocity increasing, then it decreases, then it increases and it decreases. Okay, it can have any random shape. Or here you can see it is first increasing, like decreasing. This is decreasing like this, then it decreases less, then it decreases more, then it decreases less, right? And this is a trend line here. So there is an activity that is given to you. The times of arrival and departure of a train at three. I will solve this for you in the next slide. Three stations A, B, C, and the distance of stations B and C from A. So this is the origin, right? A is the origin, and the distance A from A is given with B and for C. So you have to plot and interpret the distance time graph for the train. Okay, times of arrival and times of departure are times of departure are given here. So you have to plot time, distance, and time graph. Distance here and time here. Okay. The assumption is that motion between stations is uniform. The assumption is that the motion between stations is uniform, which means the speed is not changing when it is moving. And okay, so I have made this sort of a graph for you. You of course have to do it on a graph paper. वैसे नहीं होगा, but this is the best I can do to help you understand this. So I have plotted distance and time. With distance, what I have done, with time, what I have done is I have taken it in minutes or hours, as in I have taken time between that. So I have taken this to be 0. Okay, for this to be 0, for example 8 o'clock को वो चालू हुआ, so I have taken that to be 0, and I have taken intervals of 15 minutes, right? So if this is 0.0, then intervals of 15 minutes here. This is 15, this is 30, this is 45 minutes, this is 1 hour. Then you see that this is 3 hours 15 minutes away, right? This is as compared to 8 o'clock, this is 5 hours away. This is 3 hours 15 minutes away. So I'm going to plot accordingly. Okay. So what we see here is that when the train is at station A, it is starting from station A. Okay. So distance we are taking from A, which is our origin or point of reference. So A पे जब है तब distance is also 0, and we have taken time also to be 0. Okay. It arrives at 8 o'clock and it departs at 8:15. So it stays there for 15 minutes. 15 minute वहां रुका. Okay. So at point A, it stays for 15 minutes. Okay. It stayed at station A for 15 minutes. After a while, at 8:15, it started to move. And with this, we have to assume that it is moving at a constant speed. Okay, at 8:15 it moves, and at 11:15 it reaches B. 11:15 is 3.15. It is away from 3 hours 15 minutes away, right? So 3.15 is this. ठीक है, 3.15 पे we have 120 kilometer, 3 hours 15 minutes में 1 hour it has covered 120 kilometers. So it is reached here. Okay, it stays at station B for 15 minutes, which means it is not covering any distance for these 15 minutes. So 15 minutes yahan ruka here. Okay, again it starts to move, and 5 hours after it started from point A, 5 घंटे A से चालू होने के बाद 5 घंटे बाद, that is here, it has reached station C. It has covered 180 kilometers and it is here. ठीक है? And then it again stands at station C for 15 minutes, which it means it is not moving. So now we join these points to get a graph. Of course you have to use a scale. मैं scale नहीं use कर सकती, इसलिए ऐसे बना है. You will see that you can get this kind of a graph where the distance for these 15 minutes यहाँ पे at station A, at station B, and at station C for 15 minutes the train is stopping, so the distance moved is 0, but time is 15 minutes ka interval. Okay, this is the kind of graph you will get for this. Then you come to the next question, where the distance covered by Firoz and Sania at different times on their bicycle is given. What I have done here again is I have taken 0.0 to mean that distance covered is also 0, and that time start point is also 0. So 8 o'clock is 0. I have taken this point as 8 o'clock. And then there are intervals of 5 minutes each. 5 minute का फर्क है. So I have taken this to be 5 minutes each of these. Okay. So we start with Firoz. At 8 o'clock he was at the origin point. At 5 minutes after that he had covered 1 kilometer. ठीक है. 10 minutes after that he had covered 1.9 kilometer. 15 minutes, 15 मिनट बाद he had covered 2.8 kilometer. Okay, 8:20 को, that is 20 minutes, he had reached his destination 3.6 kilometer. Now you have to understand, now you join it, okay? This will not be a straight line. You have to understand this कि because this I am doing on a paper, इसलिए ये जो gap है, this is less than this gap, right? You can see. ये ऐसे नहीं होना चाहिए. This should be equal. So if there are 2 blocks for 10, for between 5 and 10, there should be 2 blocks between 0 and 5 also. इसलिए ग्राफ थोड़ा सा आपका ना ऐसे shift हो जाएगा. But the basic trend remains the same. Okay. It is not a straight line. You can also see from this that he's covering 1 kilometer in these 5 minutes. Then he's covering 0.9 kilometer in these 5, and then 0.9 and then 0.8. Okay. So he's covering different distances, which means the speed is not uniform. इसलिए line will not be exactly, it will not be a linear relationship. Okay. With Sanya covered 0 पे she was here. Then 5 minutes में she was at 0.8. Then 8-10 minutes में she was at 1.6. 15 minutes में she was at 2.3. Then she was here at 20 minutes पे she was at 3 kilometers. And at 25 she reached 3.6. Now her line will be something like this. Right? Please plot these graphs, or इसमें you don't have to don't use a ruler, because this is not a straight line again. दोनों का straight line नहीं है. You have to draw with hand, but be sure कि you make it as straight as you possibly can. Okay. ठीक है. So there are questions. What is the nature of the distance time graph for uniform and non-uniform motion of an object? You know nature of distance time graph uniform के लिए क्या होगा? Where it is uniform motion is where it is traveling same distance in equal intervals of time, which means the graph will be linear. ऐसा होगा. Okay. What is the nature for non-uniform motion? Non-uniform can be ऐसे, it can be anything. It can be anything. Okay. Actually, it can't be like this. It can only be like this. It cannot come down because you are not going back in distance. Okay. So it will always move up ahead, but unless you are stopping, which means it will be like this. If you stop like this, then you move in this slowly, then you move fast, then it will be something like this. What can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? Motion of an object whose distance to time graph is parallel to the time axis. What does that mean? Distance remains the same as time progresses, which means that object is not moving. Do you understand? It is not in motion. It is not moving. Okay. What can you say about the motion of an object if its speed time graph is a straight line parallel to time axis? If the speed time graph, okay, or velocity time graph. Velocity time graph is straight line parallel to time axis, which means velocity is not changing. It is uniform motion. This is velocity time graph uniform motion. This is distance time graph uniform motion. Do you understand? And velocity time graph for non-uniform motion can be If it is increasing with uniform acceleration, it will be like this. For non-uniform motion, the speed time, the distance time graph will be कुछ भी. Okay, all right. What is the quantity which is measured by the area occupied below velocity time graph? Velocity time graph के नीचे जो ये area है ये क्या cover करता है? What does it calculate? It calculates the distance covered. Okay, ठीक है? Okay, let's move further. Okay, so we are at the end of this part. What have we learned in this part? We have learned about the graphical representation of motion. Okay, now all of these points that you will see ahead are the ones that I already covered in the previous slide, but I want this to be as a summary so that you can just look at this part of the video and then you can see अच्छा मैंने ये सब पढ़ा है इस video में. All right, so you have distance time graph for uniform motion, which where there is equal distance and equal intervals of time and the speed and velocity does not change, is a linear variation. Okay, like this. Distance time graph for non-uniform motion is a non-linear variation. It can be anything. It can be, if velocity is increasing, it can be like this. If velocity is decreasing, it can be like this, you know, or it can be if कभी increase कर रही है, कभी decrease कर रही है, ऐसे it can be like this. Okay, it won't go down unless it is in the distance ऐसा है ना, it is distance upon time, so it won't go down, distance negative में नहीं जाएगा. Slope of a line, इस लाइन की जो स्लोप है ये पार्ट जो है, this gives us the speed. Velocity time graph for uniform motion where the velocity does not change, is a straight line parallel to the x-axis. Where the velocity is not changing, it is constant with time, so it is not changing like this. Velocity time graph for uniformly accelerated motion where velocity changes equally in equal intervals of time, is a linear variation. Okay, and area under the velocity time graph gives the distance covered. These things give the distance covered. Okay, clear? So this is what we have done. Please watch the final parts. Parts 3, 4 and 5 I think are left. No, I think parts 4 and 5 are left. This is part 3. Okay, so please watch those two parts also. We will finish off this chapter. If you like this video, please share it. Please like it on YouTube. Please subscribe to this channel. Please press the bell icon. Okay, so that you get notified whenever we post new videos. Okay, chalo. Thank you. See you. Bye.